Hey guys, today we're going to talk about deductive reasoning. We're going to jump right in and go ahead and give you your definition of deductive reasoning. Okay, and what deductive reasoning is the process of using logic to draw conclusions from given facts definitions and properties. Okay, it's the process of using logic to draw conclusions from given facts, definitions, and properties. So basically, to be deductive reasoning, you need to be able to give facts, definitions, and properties to make sure that the statement is true. Okay? So what we need to do is go through these few examples and decide whether the information that they give us is inductive or deductive. Basically, if it's inductive, you're not going to have any given facts, definitions, and properties. It's just going to give you a piece of information. It's not going to give you any information to back up that claim. But what deductive reasoning does is give you all the information to back up that claim. Okay, so let's go ahead and take a look at the first one. It says, there is a myth that you can balance an egg on its end only on the spring equinox. A person was able to balance an egg on July 8th, September 21st, and December 19th. Therefore, this myth is false. Okay? They don't really give you any detailed facts or definitions or properties. They just give you a piece of information. Okay? So this guy is going to be inductive. Okay? This piece of information is inductive because it doesn't give you any facts or properties or anything like that. Okay, number 2. It says, there is a myth that the Great Wall of China is the only man-made object visible from the moon. The Great Wall is barely visible in photographs taken from 180 miles above the Earth, and the moon is about 237,000 miles from Earth. Therefore, the myth cannot be true. Okay, well this little statement gives you all kinds of information. It gives you some facts, and it gives you detailed information. So we know that this one is going to be deductive. Okay, it gives you a ton of information, so it's going to be a deductive reasoning. Okay, and number 3. It says, there is a myth that an eel skin wallet will demagnetize credit cards because the skin of the electric eels used to make the wallet holds an electric charge. However, eel skin products are not made from electric eels, therefore the myth cannot be true. Is this conclusion a result of inductive or deductive reasoning? Well, in this one, it does give you a bunch of information, but some of it is a definition. Okay, for example, the skin of an electric eel used to make the wallet holds an electric charge. Okay, that's giving a definition of what that skin of the electric eel is. It gives you detailed information that helps you decide whether the statement is true or false. Okay, so this guy is going to be deductive. Okay, deductive reasoning. Okay, so that is inductive and deductive reasoning, deciding how to decide whether something is true or false. Okay, the next thing we're going to talk about, very important law, is the law of detachment. And it says basically, if P then Q is a true statement, and P is true, then Q is true. Okay, so we're going to take a look at this for a few minutes on the next page. Okay, we want to determine if the conjecture is valid by using the law of detachment. Remember, the law of detachment is if P then Q is a true statement, and P is true, then Q is also true. Okay, it says in the World Series, if a team wins 4 games, then the team wins the series. Okay? So the situation says the Red Sox won 4 games in the 2004 World Series. So, since the given was that they only had to win 4 games, and the situation was that they won 4 games, the conjecture that the Red Sox won the 2004 World Series would be absolutely valid. Okay, so this statement would all be valid. Okay? Number 5. It says, if side lengths of a triangle are 5 centimeters, 12 centimeters, and 13 centimeters, then the area of the triangle is 30 centimeters squared. And we know that the area of PQR is 30 centimeters. Conjecture, the side lengths of PQR are 5, 12, and 13. Well, while we know that this may be true, you might have side lengths of 5, 12, and 13 that make an area of 30 centimeters. You could also have dimensions that would be different, but would still produce an area of 30 centimeters squared. Okay, so just because you have an area of 30 centimeters squared, that doesn't mean that they have to be 5, 12, and 13 centimeters. They could be something different. So this would be not valid. Okay, example number 6. It says, if a student passes his classes, the student is eligible to play sports. And it says, situation, Raymond passed his classes. Okay, so we know Raymond passed his classes. And then it says, or Ramon maybe, is eligible to play sports. Well, since it's given that if he passes classes, then they're able to play sports, then we know Raymond is able to play sports. So this is a valid statement. Okay. Next law. Law of syllogism. Okay, law of syllogism says if P to Q and Q to R are true statements, then P to R is a true statement. So if P to Q and Q to R are true statements, then P to R is a true statement. Okay, so let's go through some of these examples that talk about the law of syllogism. Alright, let's go over a few examples of the law of syllogism and how you can decide if a conjecture is valid based on it. Okay, so number 1 says if a figure is a kite, and we're going to go ahead and label these. Okay, remember after your if statement is always going to be your P. Okay, so after your if statement will be your P. So if a figure is a kite, so is a kite would be your P. Then it is a quadrilateral. After your then statement is going to be your Q. So the quadrilateral would be your Q statement. And it says if a figure is a quadrilateral, once again, quadrilateral is your Q. If a figure is a quadrilateral, then it is a polygon. Okay, so that would be your second then statement. So that one's going to be your R. Okay. So it says if a figure is a kite, then it is a quadrilateral. We need to see if P goes to Q, then Q must go to R, and if that happens, P also goes to R. That will make the conjecture valid by law of syllogism. So it says if a figure is a kite, then it is a quadrilateral. So we know we go from P to Q. And then it says if a figure is a quadrilateral, then it is a polygon. Okay, so Q also goes to R. And since both of those things are true, then P goes to R. Okay, so we know that this statement is going to be valid. Okay, let's take a look at another one. Okay, it says, the second one says, if a number is divisible by 2, then it is even. If a number is even, then it is an integer. Okay, so let's go ahead and label our stuff. If a number is divisible by 2, then it is even, so that would be our P. Then it is even, that would give you your Q. And if a number is even, again giving you your Q, then it is a integer. That would be your R. Okay, and it says if a number is an integer, then it is divisible by 2. Okay, if a number is an integer, then it is divisible by 2. Well, that's not always going to be true, because you could have a number that is an integer, say 7. Well, 7 divided by 2 is not evenly divisible. That would be 3.5. So we know that this statement is not valid. Okay, let's try another. Okay, number 9 says, if an animal is a mammal, okay, so that would be your P statement, then it has hair, that would be your Q. If an animal is a dog, that would be your R. And then it is a mammal, that would of course be your P again. Okay, we have P going to Q, so it says it is a mammal if it has hair, okay, so it is a mammal if it has hair, so it goes from P to Q, and then you have to go from R to P, which says if an animal is a dog, it is a mammal, which is true. So that means that R goes to Q, which would be if an animal is a dog, then it has hair. Okay, so you know this one would be valid. Okay, what I would like you to do for the next few moments is to decide whether each of these different statements are true by inductive reasoning or deductive reasoning. Okay, go ahead and explain why you think that is. See ya.